Good evening. Welcome back. I gotta apologize. Start with apology. Uh, I was drunk and I was feeling naughty, so I called you some names. I'm sorry. I didn't mean it. It was just a joke. Okay. I'm naughty. Okay. I'm very playful, naughty kind of person. So, um, it's just a joke. Okay. So if I called you names over the last weekend, my apology. Okay. But we are friends, right? I mean, I don't even have to apologize. But just in case, okay? If you if it was unpleasant, yeah, I'm sorry, okay? But we are friends by now, right? So between friends, yeah, we don't apologize after making some jokes. No, that's between acquaintances, right? Between friends, we don't apologize about jokes, right? So, okay. Now, uh, so I finished watching that Blueprint, the BBC documentary series. It was fantastic. It's just that they're anti-climate changes, so they got it wrong on that account. And I suspect, I don't know, but I suspect they did lie many times. And many documentary makers, filmmakers, I know, okay, because in order to make a nice narrative, to make a political point, sometimes they make things up. Okay, so they kind of cross the boundary between reality and the fiction, like filmmaking, movie. Documentary is supposed to be about facts, but documentary filmmakers they cross the boundary between reality and fiction sometimes. Okay, so many of things I saw in that Blue Planet 2, yeah, I can tell it's kind of staged, right? For example, coral bleaching. What are the odds? Okay, come on. Out of this all this ocean, trophic ocean in the world, what are the odds? Okay, it just happened to be the time and place bleaching was happening, so they took a shot, filmed before and after the bleaching. I don't buy it. I don't buy it. No. One theory, they could have done something. I'm perhaps they did something to the ocean themselves. Yeah, BBC people. Maybe they spread acids to destroy those corals to make a point, to make some dramatic contrast between dead corals and live corals. That's one possibility. Okay. Yeah, if they did, then they are morally culpable, right? Because they did this. So if you run the camera very slowly and if you play at regular speed, that means the footage itself is very fast, like fast forward. Okay. So they did that with the coral dying, bleaching, right? And I cannot believe, okay, they were there at that time and that place bleaching was happening. Okay, I doubt it. My guess, probably they pour some acid in the coral, release some acid, and in order to make that footage, the coral dying, bleaching, that would be my guess. Okay, so if they did, oh, that's morally wrong. Very highly immoral act. So anti-climate changeism, because it's unsound ideology, sometimes they resort to lies, making up stories and making up science. Scientists, engineers, I mean, you cannot believe them, right? Not always. Sometimes they lie too. They're human beings. So. And some scientists, so-called scientists, featured in that documentary Blue Planet 2, so ignorant, right? Ice ocean, the Antarctica or Arctica, the ice melting, the sea level will rise. No, it won't. It won't rise at all. Even if it rises, it will be insignificant. All right. They don't know the basic physics. Okay. You have cup and water, and put ice in there. Yeah, the level of water will rise because you have brand new ice in there. But in the world, ice is already there, right? So now you have new height of water level, right? Now this ice is floating. As this ice melts, the water level will stay exactly the same. All right. If ice is anchored at the bottom, yeah, the as ice melt, uh, the water level in the cup will rise. But you have to understand this, okay? Ice is very brittle and fragile, right? And there's strong winds in Arctica, Antarctica, okay? So it's like tip of iceberg. Even if ice is anchored at the bottom of the ocean, okay? Even so, the amount of ice above the sea level is like very little compared to what's beneath the ocean. Why? Because of the fragility of ice. That's why. Okay, it gets all evened out. Ice is not like rocks. You don't get to see ice mountain, right? It's because ice is very brittle and fragile compared to rocks, right? Erosion by wind. So, yeah, even if ice is anchored, not much percentage is above the sea level, anyways. So even if all the ice melt, sea level will not rise. All right, it will stay more or less the same. Okay, so they don't know. Okay, so why are they so big about climate change? Climate change because they want to be relevant. They want to be on the spotlight. Okay, so they are taking advantage of this situation in order to be famous and in order to get a lot of funding for their research. Yeah, it's about money, power, and fame. Nothing more. Right? It's not about saving the planet. No, it's about them becoming more powerful, famous, and rich. That's why they're doing what they're doing. Scientifically, there's nothing to worry about climate change. Right? They're saying all that, warning people, scaring people about the rising sea level, on, and maybe they don't themselves don't know, or maybe they themselves don't care, or maybe they themselves know that it won't happen, and they are lying to us. Either way, whatever way, they are wrong. Okay, so sea level will not rise. And when it comes to coral bleaching, I think they're making that up. Probably they spread chemical or not. Okay, yeah, I deny them. Their allegation. I deny it. They may call me denier or whatever. Yeah, well, they don't call me anything because I'm nobody. I'm not famous. Oh, there's spiral. I gotta get the spiral. Okay, so. Okay. We'll take 5 minutes later, okay? Yeah, let's take 5 minutes. Okay. So, we are metaphysical ghostbusters, okay? Whenever we see a wrong, bad ideologies, we go after them. That's our job. One of our jobs, okay? So, as humanologists. So, in this Blue Planet 2, I can see all the places where they're staged, all right? There's this live turtle, sea turtle, kind of like entangled, it was still live, entangled in some kind of like fishing net or plastics or whatever, right? I think that was staged because it's not likely that this camera crew, BBC people, got there just in time before the turtle died. Okay, probably they caught a turtle and wrapped some plastic around it. Okay. Oh come on, you got there just before the turtle died? No, that's not likely. These guys so obvious, right? Liars typically are like that, okay? They're so obvious in their lives. Alright? They think they can fool people, but not me. Not for long. Okay? By the way, I made the horsetail, the plant, foreign horsetail vodka, and I don't think it was a good idea. I smelled it, it didn't smell good. And also, even that edible horsetail, it does contain some silica, okay? So it didn't feel right, so I discarded it. Alright? FYI. Well, happy Monday, by the way. And I hope you had a nice weekend. And also another thing, they claim that they collected all these plastic bags out of feces of a baby bird. I don't think so. Okay, big piece of plastic bags. They said they found it in the feces of baby bird. I don't think so. That's utter nonsense. Okay, they're making that up, as far as I can see. All right. So yeah, plastics. We need plastics, and if you see plastics in the ocean, pick them up. Have some international, for you know, collaborative team so that they pick up all the plastics out in the ocean, no problem. Or even fishing boat, let them pick up plastic waste in the ocean. Okay, no problem. Yeah, just pick them up. What's the problem? No problem. Okay, and recycle them. Right? Yeah, these guys have been so obvious in their lives. Okay, so I don't buy a single one of it, any one of it. All right, so let's talk about relativity. Okay, because I was thinking about it a little bit. Again, it's a review. We already talked about it, so we'll just touch on it briefly. So, special relativity. Okay, it starts with the wrong assumption. The speed of light is constant. It's not. I mean, relative speed of light is constant. It's not. Okay, so first of all, speed of light in vacuum is constant, and also speed of light through a uniform density medium is also constant, but they are different. As light pass through water, it slows down. Speed of light in water is not the same as speed of light in vacuum. Okay, so speed of light is very much variable. All right. Now, Einstein thought about this thought experiment where he's racing with light, particle, photon. Okay, let's make it easier. Let light. You have this cistern, this water aquarium with no fish in it, just a lot of water. Okay, aquarium, long aquarium. Okay, and just flash the flashlight so light pass through the water, right? And you you just run in the air, not in the water, so that you can outrun light. All right. So yeah, you can measure relative speed of the slow down light particle photon because it's going through the water, and then you as an observer is going as fast as you can, or in a machine, whatever, right? And you measure the relative speed of light from this moving observer going in the same direction. Okay, then yes, you can start to see relative speed of light being slowed down, being slower. All right. Okay. So yeah, you can experiment to verify that Einsteinian theory is wrong. Okay. There's no such thing as time dilation, length contraction. There's no such thing. Okay, so Mr. Einstein was wrong. All right. Yeah. Oh. Because yeah, Einsteinian assumption that speed of light, relative speed of light is constant. That's why time should slow down and length should contract. But length contraction, time elongation, time dilation, whatever. It just doesn't make sense. Okay, it's not scientifically, logically, mathematically sustainable position, right? Because you can think of a medium that slows down light a lot further than water, like very thick and transparent, like glass. Yeah, pass the light through it. Light will slow down. Okay, so it will be very easy to catch up with light and measure the relative velocity of this very fast moving car or machine, airplane, and to measure the speed of light going through very dense, thick, transparent medium. Okay? You see relative speed of light is slower than speed of light measured by static observer. Okay? Yeah, it is easily verifiable. It's very easy to disprove Mr. Einstein's theory, okay? Relative theory. Because it's wrong. Okay. How general relativity? Yeah, we talked about this before, so I don't see any reason to why. So basically it's this, okay? If forces are equivalent, okay, so he says like light will bend in the gravitational force field, okay? So there's nothing special about gravitational force, okay? So light should bend also in electromagnetic field. Light should bend also in this wind field, wind force, particle pushing, wind force. And light should bend also in magnetic force field as well. Okay, because there's nothing special about gravitational force. Okay, but it makes absolutely no sense. You have plus and minus this electric field. Okay, plus polarity and minus polarity. Okay, so light is electrically neutral. So light, there's no reason why light would bend upward toward plus or toward minus, right? Now, light is also magnetically neutral too. So there's this north pole, south pole, this strong magnetic field. There's no way light would bend like toward the north pole or south pole. Okay. By the same token, light has no mass. Okay. There's no way, there's no need, there's no rhyme or reason why light should bend toward the gravity, because light does not have any mass. Okay? How about inertial force? Well, inertial force, yeah, if there's acceleration, you pull back, right? Inertial force, you can construct it in terms of gravitation, like, you know, or a rocket with the engine force, action reaction, engine force, a rocket in the space. Yeah, the inertial force, right, with constant acceleration, right? Or gravitational force, constant gravitational acceleration, and or in a magnetic field. Yeah, you are in an elevator. Your ceiling is like south pole. Your floor is north pole. Okay, and outside of your elevator, there's north pole up there and south pole way down there. So your elevator accelerates upward, right? Electromagnetic field. Yeah, you charge the ceiling of your uh, elevator as positive, and out there you have negative charged plate, and the floor of your elevator you charge it with positive, and out there down there you charge it with plus, so that your elevator kind of move up, right? Yeah, you can create the kind of acceleration, or your elevator is floating in the ocean and you have strong wind pushing you. Yeah, wind force. Okay, all kinds of forces. Yeah, I mean, if you look at light within this elevator, it will make this parabolic trajectory because you are moving up and light is going straight, right? Yeah, in any of those cases. But it's the way this guy observer inside of elevator, that's how the light particle looks like. Okay, but it's just a perception. Light does not bend. It looks as though light bends. Okay, opposite the direction of your acceleration. Okay, but light itself does not bend. So yeah, Mr. Einstein was very, very mistaken. He was confused. So he was wrong. Okay? Yeah. That's why he failed in this unified theory, because it just doesn't work. Okay? All this astronomical data or other experimental data, they fudged up the numbers. They lied to us, all of us. Okay? It's all politics in science. Okay? Because first, they said Einstein was wrong when Einstein was quite small. But later on, Einstein became international superstar, even outside of science community. Okay, so now they have to kneel down, obey, fudge up their numbers, and first, yeah, they didn't observe any difference in this whatever Mercury, this light bending behind the sun. They didn't observe anything like that. So they were telling the truth back then, okay? But now that Einstein became very big, they're like, oh, okay, we give it to him, okay? So they lied for him. A sad chapter in science history, right? What can I tell? What can I tell you? That's what happened, as far as I can tell. Yeah. Uh, yeah, I cannot drink vodka tonight because I drank too much over the weekend. So one day, my esophagus it's too like scratchy. Maybe I just drink beer and wine. Um, that's fine. Okay. Let's get back to mathematics. Okay, so we'll take 5 minutes break and then we'll do more mathematics. Okay. Yeah. Unless something else comes up. All right. All right. Let's take it like 5 minutes. Okay. Yeah. There we go. Okay. Yeah, I'm not quite ready to get back to mathematics. Okay, let's talk about relativity. Okay, so it's kind of fun. Do you remember that Blue Man Group, the drummers, percussionists? Well, not my cup of tea. Okay, they paint their body in blue and expressionless face, some modicum of sense of humor, but not my cup of tea. Okay, but yeah, imagine yourself being positive, your entire body being positively charged. Okay, and you're in an elevator. Okay, and So you're positively charged, okay, and there's this electrical field. So on your right, there's this positively charged plate outside of your elevator, and your left hand side, the negative charged plate. So in order to apply this uniform electric field, right? So your body will move to the left, and you feel the pressure because your body is positively charged, right? But you're not moving. Why? Because your elevator is fixed on the ground. Your body moves toward the left, right? Your body is positively charged, right? Yeah, like the blue man. So as if you feel something like gravitation, okay? You are being pulled toward the left, where this negatively charged plate outside your elevator is, and on your right side, right outside of the elevator, the positively charged plate, so it will push you because your entire body is positively charged. Okay, you will feel just like gravitation toward the left. Okay, now and then you see a light particle, photon, passing right next to you. You look at it, okay? Will it bend toward the left or toward the right? I don't think so. Because light is neutral in terms of electricity. Photon is neither negatively nor positively charged. Okay? So, same way with your magnetism, it's all the same. Okay, well, wind blowing, and if your elevator, okay, it has a window, so wind is blowing from right to left, and you feel the pressure, and so you move toward the left, and then you hit the wall of this elevator, and so that you don't move, but you do feel the force of wind force, okay, and then you see a photon traveling, passing by. Would photon bend? Can you blow the photon? No. Why? Because photon does not have any mass. Photon will just go straight. It will not be influenced in any way by the wind blowing. Okay? Make sense? Yeah. And then there's gravitation. Okay, again, photon will not, there's no rhyme or reason. Photon would bend toward the gravitation. Why? Because it has no mass. Okay? Yeah. So Mr. Einstein was confused, and he confused all the other physicists. False prophet. Inadvertently, so he didn't know he was wrong. But then again, all the Old Testament biblical false prophets, I'm sure they thought they were right. They inadvertently misled people. Like Mr. Karl Marx, Mr. Sigmund Freud. They were false prophets because they misled people and they were wrong. But, and also they are prophet because they are famous. Highly influential person, that's what prophet is. I'm not a prophet because I have no influence on anybody. Maybe people around me just like anybody else, right? Yeah. But prophet is somebody very famous who has at least national level influence and fame. That's what prophet is. Okay. And when they're wrong, they're false prophets. But all the false prophets, they don't know they're wrong. So we cannot quite put a moral blame on them. That's not fair. They thought they were right. Mr. Karl Marx, Mr. Dr. Sigmund Freud, Mr. Albert Einstein, they thought they were right. So we cannot put a moral blame on them. Even if they misled so many people over centuries. Well, over a century. It's not their fault. We just need to correct them because they erred. We have to correct ourselves. That's our job. Okay. Okay? Yeah. So I did my job. Okay, so we did our job well. So, yeah. So, in general relativity, this equivalence principle, this gravitational force, whatever other forces, and acceleration force, inertial force, right? Inertial force. Einstein said they should be equivalent. Yes and no. Okay? Because the difference between inertial force and other forces is this. Other forces can happen when things are not moving. Electric force, magnetic force, gravitational force. Well, wind force, you turn on a fan, so yeah, air particle is moving and the fan is moving, right? But you yourself, on the wall, left wall of the elevator, because your right wall of the elevator has this window. So it's front and back window, so that window, it has a window, but on your left hand side, it does not have any window, so that you can lean on that wall, okay? So on the right hand side, you turn on the fan, really strong fan, like in this airline, they study this fluid dynamics, right? Oh, they have very strong fan. One of Jackie Chan movie has that scene, okay? It was hilarious, okay? Yeah, yeah, those laboratories to study fluid dynamics, aerodynamics in a laboratory for airplanes, okay? Yeah, they have those really strong fans, right? So yeah, you have a fan going on, the air particles moving, but you are not moving at all. You're static, you are just leaning on the wall, getting all the wind blowing on your face, on your body, right? Pushing you toward the left wall, okay? So, yeah, all these forces, they can happen when nobody's moving. I mean, when you are not moving, an object. Wind force, yeah, the particle, air molecule, they are moving. That's what's pushing you, right? But other than that, nobody's moving. Okay. You are not accelerating. Okay, but accelerating in this body, this rocket, inertial force, like when your car accelerates, your body kind of pulls back, right? They kind of inertial force, they are exception. They are not equivalent to other kind of forces. Why? Because acceleration force can happen only when this body object is moving with an acceleration. So there's fundamental difference. They are not equivalent. And Mr. Einstein was wrong to posit that there's equivalence. No, they are different, fundamentally different. Okay, so static versus dynamic, moving versus non-moving. Okay, that's like polar difference. They are not equivalent. Okay, so that's the key wrong assumption that he made that invalidates general relativity theory. Okay? Now, special relativity, how to disprove it? Yeah, we did so, but you need to. It requires some diagramming. Okay. So we are not going to do it. We already did so. Okay. Maybe I just verbally describe to you, right? Yeah, I can do that. Maybe after 5 minutes. All right. it's not. It's nice to take a break from mathematics, right? So, yeah, the Einsteinian theory is a very big theory. So this proof thereof is very important. Okay, because so many people are wrong now. It's being taught in everywhere in the world. All these physics schools, high schools, colleges, Einsteinian relativity, special and general, right? Yeah. We also disproved the Alfred Marshallian supply and demand curve too, right? A while ago. We'll do it again, okay? Because it's important. It's being taught in every microeconomics introductory class, alright? So it's important to disprove it again and again and again. Okay, so okay, special relativity. Okay, yeah. Disprove thereof without drawing any diagram, just with mere words, just like we did with general relativity. Okay, let's attempt that. Let's try that. Why? We don't always have whiteboard and pen, though we have it here. But I cannot erase anything, not yet. Okay, so we're still it's ongoing project. This partition function, right? Yeah, we cannot spare any room for a wrong theory, relativity theory. Okay, so let's take 5 minutes break. Okay, so and then we'll see what's what. Okay, all right. Okay. Putting vodka in children's bottle. Oh man, I'm so bad. That cheapest, okay? That's the only reason. Doesn't mean anything, okay? Yeah, my families and friends suggested that I open up the curtain because typically I keep the curtains drawn because I mean I want some privacy, and but they say yeah, I mean physically and mentally it's healthier to get some sunshine into the house. So yeah, so I open up all the curtains in this house. Okay, so yeah, I listen. So special relativity. Okay, just thought experiments without any drawing, painting, pen and whiteboard. Okay, we just narrate because we are that good. Okay, we can disprove with mere words, without any pen, writing down, drawing diagram. It's not necessary. So the story goes like this: there's a lady, right, and there are three suitors in a train with three cars. It's three-car train. A lady is in a car next to the train, right? So the three guys, they're suitors, and it's like dating show, okay? One lady, three guys, okay? So two scenarios when let's say I don't want to play a lady, okay? So let's say, okay, how about this? Three ladies and me. It's like Bachelor's TV show, okay? Let's fantasize. Let's daydream. What's wrong with that? I'm not saying. I know I'm not popular among ladies, okay? So we just fantasize, okay? One day I become a billionaire, millionaire, okay? So this humanology become big later on, okay? So I become very rich. I have a 10-bedroom mansion and 10 different colors of cars. I have pickup truck. I have SUV, sports car, limousine, all different colors, okay? Comfortable sports car or regular sedan and everything, okay? 10 different cars, 10-acre lot, right? So I appear in a Bachelor's TV show, okay? Alaskan Bachelor. And there's three ladies, top three contestants. They're in a train, right? Train with three cars. And I'm in my car parked right next to this moving train. And the train is moving from left to right. Okay? So when the ladies, three cars pass by, each of them throw me bouquet of flowers. I'm a guy, I mean, so that doesn't sound right. Okay, how about this? As three trains pass me by, when the when a lady is right in front of me because this train is moving very slowly, I toss them bouquet of flowers one by one when they pass by. Okay? Better. And they catch it. Because this train has a driver, okay? So, okay, 4 train cars. Okay? The driver side. Okay? And I'm in passenger side of my car because I also have a driver on the driver's seat. Okay? So, but our car is not moving. It's the train that's moving from left to right. So I toss them bouquet of flowers and they catch it, right? When they are right in front of me, one by one, okay? According to Mr. Einstein, alright? Time dilation happens. So moving train, in my clock, we adjust the speed of train such that in my clock, one lady passed me by right in front of me per 1 second in my clock. But in their clock, because they are moving, time will go slow down. They will measure it as if, by the way, the three ladies, their three clocks are synchronized. Okay? So, and they are moving the same speed. It's a train, right? So, in my clock, one bouquet per second. 1, 2, 3. Ashley, Becky, Cheryl. Oh, no, Carolina. Carol. Ashley, Becky, Carol. Alright? ABC. Me? Let's say my name is Daniel. Alright? So, Daniel distributes bouquets of flower, one bouquet per second. One, Ashley, Becky, Carol. One per second. But in their clocks are synchronized between those three ladies. Okay. In their clock, because time goes slowly than mine, they're moving. Let's say they receive this bouquet of flowers every 0.5 seconds. And it's not to scale because they are moving slowly, but it doesn't matter, okay? That's not the point here. All right? Now, second scenario. Their train is not moving. It's my car that's moving. My car moved from right to left. Okay? My car moved from right to left. Now, in my time, I only have one clock. It's just me. My driver, he doesn't need any clock. Okay? He just drives. Constant speed. Okay? My clock, I toss as I pass by from right to left. The ladies, they used to, in the standard one, they move from left to right, okay? We're gonna make it kind of look the same. So I have to move from right to left in order to give bouquets in A, B, C order. Ashley, Becky, Carol, okay? In my clock, I adjust my car's speed such that I toss this bouquet of flower to Ashley, Becky, Carol, one bouquet per second. That's how it is in my clock. But their train is not moving. So my clock, when 1 second passes by, because according to Einstein's time dilation, when 1 second passes by, in their time, their synchronized clocks, 2 seconds pass by for each. So to them, it's one bouquet per 2 seconds. That's the contradiction. Okay? When they were moving, 0.5 seconds passed for each bouquet. When I was moving, they get bouquets of flowers every 2 seconds. Every 2 seconds, not every 0.5 seconds, okay? And 0.5 is not equal to 2. So that's the disproof of special theory of relativity. Okay? QED, okay, so yeah, it's very easy to disprove Einsteinian relativities, okay, because the error that he made is at the very bottom level, elementary level, fundamental level, okay. He made fundamentally wrong assumptions, okay. in general relativity, he wrongly assumed that inertial force is equivalent to other natural forces. No, they are not. Inertial force exists only when object is moving in acceleration. All the other forces can exist without anything moving at all. With zero velocity setting, right? That's a fundamental difference. So they are not equivalent forces. Okay. In special relativity, yeah, there is in the universe, there's no such a thing as absolute speed. Everything is relative in the universe. All right. Let's imagine that you and I are astronauts. Okay, we're spacewalking, right? Nothing is connected. Yeah, we're in spaceman suit, right? And we're just floating in the empty space. No gravitation, no nothing, okay? You go that way, I go this way, right? There's no such a thing as an absolute speed. Because there's no such a thing as an absolute frame of reference, okay? It's just that you and I, relative to each other, you are going that way, I'm going this way, okay? And I measure your speed, it's like 10 meters per second. So it's equivalent to, let's say, just for the sake of argument, okay? Let's say there is sun, right? And let's say sun is not moving, just for the sake of argument, okay? Maybe relative to the sun, which is not moving, I'm not moving, it's you moving to the left, 10 meters per second, okay? Or maybe you stay the same, I'm moving to the right, 10 meters per second. Or you and I, you move 5 meters per second, I move 5 meters per second to the other direction, or you move 7 meters per second to the left, I move 3 meters per second to the right, okay? But the point is this, okay? Such a static sun, the absolute frame of reference, does not exist in the universe. Because everything is moving, and at the same time, nothing is moving in the universe. In absolute sense. It's all relative. Speed can be defined only by this Galilean relativity. Not Einsteinian. No, there's no such a thing as Einsteinian relativity. Okay, it's only Galilean, Newtonian, classical mechanics relativity. That's the only thing that exists. Okay. So, in this 4-10 second scenario, in this bachelor's TV show, okay, dating game, ladies moving toward right and me moving toward the left, it should be the same. It should result in the same result. Why? Because they are equivalent. Alright? So that's the equivalence principle, and it's Galilean equivalence principle. Okay? Ladies, I'm staying the same, and ladies moving toward the right, say what? 1 meter per second, and ladies are staying the same, and I'm moving to the left 1 meter per second. They are exactly equivalent situation. So Mr. Einstein, he got the opposite, swap upside down. When it's equivalent, he said it's not equivalent in special relativity, and in general relativity, when it's not equivalent, he assumed that they are equivalent. Okay, so he got it swapped. All right, that's why he got both wrong. But this time, we got it both right. We'll take 5 minutes break. I need some more rest, okay? Having fun? Ah, yeah. I hope you are having fun too. Okay, so we'll take 5 minutes. Yeah. Okay. So we are playing this role of being metaphysical warriors. Okay, we are knocking down all these false ideologies one by one, right? And we are zipping through it like at the speed of light, so to speak. Quoting from Madonna's song, "Ray of Light." It's a good song and fantastic dancing too. And good music video, like half of it. First half, I like it, but the night scene, it's kind of like not very good. Okay, but the first part, like describing the daily lives of Americans, okay, that part was fantastic. Okay, so huge fan. Yeah, Madonna. She's cool. She's cool. Okay, and good dancer, good singer, and good looker too. Yeah. In terms of dressing style, I guess she's okay. We can call her a good dresser too. Okay. So done with relativity, right? Let's get back to the anti-climate changes. All right. So uh, because I thought about it during the break, and let's break. And even when iceberg is anchored, like the bottom of iceberg touching the ocean ground, ocean floor, even so, the proportion between above the sea level ice and below the sea level ice will be same as the proportion of floating ice, floating iceberg. Why? I give you a minute. It has to do with equilibrium concept. Okay, so sea level will never rise. Okay, when this Antarctica, this oceanic ice melts, then sea level will not rise. The only time sea level will rise is after the ice age, because during the ice age it's so cold. There are so many snow, ice on land, not in Antarctica, not in Arctica, but on land, like on top of mountain, like glaciers. Yeah, then if all the glacier melts, the snow on top of mountains when they melt, that's what will cause the sea level rising. Okay, it's not oceanic icebergs. Iceberg, they will not raise sea level by even an inch, by even a iota. And my question to you is this: you have iceberg, floating iceberg, whose bottom is not touching the sea floor, right? When it melts, you know, by corollary of Archimedes' principle, it will not affect the sea level, right? Now, we can go even further than that. The, let's just assume, okay, the iceberg above sea level and below sea level by volume, let's say it's 10%, 90%, okay? The tip of iceberg, okay? Now, a conjecture is this: even grounded, anchored icebergs in Antarctica and Arctica, the proportion of ice above the water and below the water, it will be still 10% and 90%. And I give you like 1 minute to prove it or disprove it, because I'm gonna prove it to you. But I want to give you some time to think about it. Okay? We're not gonna write down anything because this is easy, very elementary. Okay, so because these marine biologists, their background is not mathematics or physics. Okay, it's biology. So biology majors, we appreciate them, but they are not very good at mathematics or physics. Okay, so they got it wrong. It's okay. We all make mistakes. All right. So I give you 5 minutes. Okay, I need some vocal rest. So, all right. All right. Prove or disprove. Okay. I'll give you 10 minutes. Okay. So, Okay. I guess I gave you enough time, but I'm nice, so and I'm so lazy. I give you more time, okay? Go ahead, work it out. I'm gonna tell you something else, okay? In the meanwhile, so how come all these scientists can be all wrong? I mean, is this a surprise to you? Not to me, because I'm a humanologist. I know a thing or two about ideologies as a humanologist. Yeah, ismology, right? Uh, Friedrich Nietzsche, he said something like, I mean, in Korean translation, 권력의 의지. 의지 means two things, okay? It means dependence, and also it means uh, willingness, desire, okay? So it's homonym in Korean language, okay? So I'm not quite sure what original German word it is. I think it was Nietzsche who said that, okay? So, well, what a coincidence, okay? So there are two things, okay? Will to power, a desire to have power, or there's somebody who want to be run for president. Yeah, they desire power, control, right? And they want to change other people so that other people become like themselves, right? Yeah, that's all the politicians, including myself. Okay. Yeah, they want to change the world such that their own worlds become the real world. Okay. Yeah. Even Jesus was like that. Okay. Yeah. Heaven on earth. Okay. God's will, like it's been done in heaven. So let it be done on earth too. Okay. Yeah. Jesus wanted to change the world the way he saw fit. Okay. So all the prophets, scholars, all the big figures, they are like that. Okay. Want to change the world so that the world become more like themselves. Okay. Because it makes life easier. Less difference between me and other, between oneself and others. If others become this person become happy. It makes this person's life easier, more enjoyable life. Because it's the difference that creates conflicts and pain. Okay? So that's why people want to persuade other people so that they become more like themselves. Okay? We talked about it before, okay? Humanology, all this equation, feelings equation, right? Yeah. Now, yeah, we'll touch on humanology later, okay? So there are more to it, okay? Uh, so ideologies, yeah, okay. How come all these scientists can be wrong? Oh, because they're only humans. They're not gods. They're only humans. Okay, so uh, some people who come up with brand new theories, they're like will to power, desire to power, to have big power. Okay, but before they become big people, they kind of rely on giants, right? So when you don't have power, you rely on somebody more powerful than you are. Like a child relying on their parents in animal kingdom as well, right? But as you one grows up, some people want to be powerful themselves. Perhaps it's everybody. They want to be their own bosses. They want to be parents and have kids, right? They want to have their own family, right? Yeah, that's most of us, I guess, in a way, right? So that's like people are like that. Okay, it's either you desire power yourself, and or at the time being, if you are small, you rely on somebody else's power. You lean on somebody who's more powerful than you are, as an employee, as a children, as students, right? Or political newbies, right? Like I once was. Maybe I still am. Okay, you rely on somebody more powerful, more knowledgeable, somebody with more money, more experience, a student, employee, child. Okay, so it's just the way of things. Okay, so when people see a big ideology, very powerful ideology like pro-gayism, gay marriage, right? This Mr. Representative, Democratic representative in California, I think his name is like Adam Schiff or something. I saw him on TV. He was wearing this ridiculous looking this pro-gayist this rainbow T-shirt to show support for gay marriage. Yeah, because he's not that big of a politician, so he want to rely on this big ideology, pro-gayism, right? Gay marriage, right? Yeah, he's relying on this big, powerful ideology. It's not just Democratic Party politicians, Republican Party politicians likewise. Look at President Trump, okay? Before he ran for president, okay, he didn't really care about gun law or abortion issue at all. I mean, he's New Yorker, he's Manhattan businessman, right? Big cities don't need guns because they have police officers everywhere. The only people in big cities like Los Angeles or San Francisco, Manhattan, New York, or Chicago, the only people who need guns are police officers. And big cities, they have very strict gun laws. Okay? Yeah. But in rural towns, there's so big cities are mostly liberal, rural towns mostly conservative. Okay, why? Well, I did ask many of my friends, and I did learn. Okay, so yeah, I mean, poor people, economically poor people like brand new immigrants or minorities, they come to big cities. Why? To get jobs. But when they come, they don't have any money, so they need some government assistance. Right? Yes, tax the rich, feed the poor. That's liberalism, right? So that's why they're liberal. Okay? And also, big cities, they're ethnically diverse, immigrants and, right? Yeah, liberalism, right? And, but in rural America, they are more conservative because they have jobs. They are farmers, carpenters, mechanics, right? And they have their jobs. They are landowners. They don't need government assistance. No, they want smaller government, lower tax, and also they need guns. Why? Out in the wild, not many police officers. Okay, because they're so sparsely populated rural region. Police station is far away, so they have to protect themselves with guns, and also places like Montana, Wyoming, Alaska, we have bears, we have grizzlies. We have to protect ourselves. Okay? So yeah, gun laws typically are very loose because we need guns. Right? But big cities like New York, yeah, you don't need guns. The only people who need guns are police officers, okay? So President Trump, I read his biography and his books, okay? He didn't care about abortion issue or gun law. No, he's a big city person, right? But once he joined the Republican Party ticket, this presidential election 2016, he's kind of like not a very promising candidate, president candidate. So he's a small guy in the Republican Party, right? Kind of new in politics. So he had to rely upon big ideology inside of the Republican Party, pro-gun, anti-abortion. Okay. And yes, pro-Christian. Okay. He isn't exactly Christian at all. Okay, so so scientists they are exactly the same way. When Einstein was small, okay, so I watched his biography called documentary in YouTube. Okay, yeah, so some Californian astronomer tried to measure whether Einstein's theory is correct or not during this solar eclipse. he did it twice, and both of time he didn't measure any this deviation of light at all behind the stars or Mercury, this planets behind the star during this solar eclipse. Two times he didn't observe it, but on the second time, Einstein became more famous by then. So he told his assistants, "No, no, don't publish it yet. Don't publish it. Let me think about it, okay?" And then he changed the result. And then, oh yeah, yeah, this is the proof. It's Einstein. Yeah, he was right. And that was leaning on big ideology. He didn't want to go against this big Einsteinism, pro-Einsteinism, okay? So he just went along. I think that's what happened. Okay? So yeah, scientists they're the same way. Okay, they don't go against. They don't like going against big ideologies, okay, because it makes their life too difficult. They just take the path of least resistance. Why? They're busy. I mean, they got other things to do. Their professional reputation is they cannot put it on the stake because they have hungry mouth to feed back in their houses, wife and kids. They have to pay mortgages. They have to protect their job. So we understand why they fudge up data, why they lie. Because we all do. Okay? To survive, okay? To keep our jobs. It's human condition, okay? So, will to power, okay, the desire to power and reliance on power, okay? Yeah, so that's what explains that, all those things, okay? So, when it comes to gold, not Goldbach, but iceberg, give me 5 more minutes, okay? Now I'm asking you to give me more time because I need some vocal rest, okay? Yeah, we'll go ahead and prove that equilibrium concept. Grounded, anchored iceberg, having same proportion of above sea level ice and below sea level ice. I prove that to you verbally, okay? Just give me 5 minutes. I need some vocal rest. So. Alright, thank you. Okay. Okay, so it's a good news, right? It may not be gospel, but it's a good news. It's based on not in Bible, but in science, right? Sea level will not rise. Why? Because all the ice, land ice, they already melted. Okay, back in the days during the ice age, entire Canada and big part of America were covered by ice, land ice. They are the only one they can, when melted, they can raise the sea level. But they are already gone. They're already melted because in this day and age, we are near the end of this cycle, global warming, cooling cycle. So all the ice, they can raise the sea level. They are the land ice. It's already melted. Okay, so sea level will not rise anymore. That's a good news. Okay, now let's, without further ado, let's go ahead and prove this. Okay, equilibrium concept. Okay, if think about Antarctica. Okay, for the simplest of sake, that's what we need for modeling, mathematical modeling, right? Physical modeling. You have this even sea level, okay, and there's this ice that's iceberg whose bottom is touching uh, the sea floor, right? So you have ice mountain, seaberg, sea iceberg, right? But Antarctica, Arctic Ocean, the wind is very strong, so they even the ice. So when you go to Antarctica or Arctica, when you see it on television documentary, it's all flat. You don't get to see ice mountain. There's no such thing as ice mountain because ice is very fragile and brittle. They are very easy to break. Okay. So yeah, wind, Arctic wind, subantarctic wind, they even the ice level. That's why it's all flat. Okay. Now, if the above the sea level ice is bigger than 10% volume, and then wind will even it to a point where it's less than 10%. If that happens, part of this iceberg break away and it become floating iceberg. Why? Because less than 10% of this iceberg, maybe it's like 5%, okay? Less than 10% of iceberg is above the sea level. So now more than 90% of iceberg, like 95%, is under the water. So there's this buoyancy force. Archimedes' principle, okay? So it will break apart part of this iceberg. So the equilibrium point, yeah, is 10% and 90%, even when the iceberg is grounded, anchored. Okay, because if it's above 10%, wind will blow, cut them down. If they cut more than 10% of above sea level ice by volume, and then it will start to float and break apart from the rest of the iceberg and start floating and become floating iceberg. Okay, so that's the QED. Right. Very good. This is very incidental benefit of studying mathematics, right? Because mathematics is so difficult, the rest is so easy, right? And mathematics because so boring, the rest is so interesting, right? And so easy. Yeah, that's one benefit of studying pure mathematics, as pure as partition function. Okay, incidental benefit, right? Yeah. So what we do during while taking a break from mathematics actually is by far more important. Okay. No worries. Okay. So yeah, you're not gonna lose any coastal area cities or sandy beaches. You're not gonna lose any one of them. Okay. Even if all the Arctic, Antarctic ice melt away, you're not gonna lose a single thing. Okay, sea level will not rise by a single inch. Not gonna happen. We just scientifically prove that mathematically, right? Physically. Yeah, it's physics, mathematics. Okay, so yeah, it's this Korean educational emphasis on physics and mathematics. They were correct. Okay, back in the days when I was in middle school and high school in South Korea, yeah, I didn't like it because it was so difficult to learn English, mathematics, physics. Okay, oh, chemistry, biology. That was not easy. History, literature. That was not easy at all. But now I can see they were right. Yeah, the Korean parental generation of mine, this priority in education, they were correct. And I thank them. Okay. And also I have many professors, teachers, instructors in America as well. And they taught me very well as well too. Okay. I owe them all. Okay. I'm pretty sure that American public schools, they have good teachers, educators. Oh, no doubt. Yeah, so we achieved three things in less than 2 hours. We disprove again anti-climate changeism, special relativity, general relativity. We disprove them all mathematically with mere words. I mean, Bible is just words, right? But very powerful words, nonetheless, right? Mere words. Yeah, I'm citing X-File episode. Something. Joe Chunks from Outer Space. One of my favorite episodes in X-File, right? He was talking about hypnosis. Okay, so woo. That's not what we're doing. Okay. Yeah. So I was listening to NPR before I went to work when I was doing workouts, like push-ups and sit-ups and whatnot, right? They were talking about this. Why don't we take 5 minutes break? I'm losing my voice. I need some vocal rest. Okay, we'll take 5 minutes. Okay. Maybe 10 minutes. Okay. We'll take 10 minutes. Okay, we are back. Yeah, I picked some spring shoots, spring leaves. It's spring harvest season. It's willow tree leaves. Okay. What I have is willow tree branches, small bricks, and bark. Okay, that's what I have here. But I have now. I rinsed it off once in cold water. So, yeah, that's what I did. And the wild rose spring shoots are coming, but it's not quite ready yet, so I didn't pick them. But maybe next weekend, or maybe tomorrow. I don't know. They're growing very fast. So yeah, in spring we harvest. I mean, I do. I harvest the spring edible tree leaves. But when it comes to that farm, that horsetail, it's kind of tricky because the small ones they contain silica. Okay, so it has to be at least like something like 5 inches or high. Yeah, too many rules, right? Because yeah, I did remember, but I kind of forgot, so I have to throw them all away because yeah, I felt some silica in there, like silicate. Yeah, oh, it can cause kidney stone. Okay, it can damage your kidney. So I throw them all away just to err on the safe side. Yeah, so ferns they're tricky. Okay, like these fiddleheads, you have to boil it and then get rid of all that water, right? Too much work. So yeah, I don't deal with ferns. All right, it can be toxic. It can damage your liver or kidney. Okay, so it's good. Ooh. Taste of Alaskan spring, right? Yeah. Ooh. So, yes, during the summer, what do you harvest? What do I harvest? Mushrooms. Because summer, it rains quite a bit in Alaska, okay? Kind of late summer. During the fall, yeah, berries. That's berry season. All wild, edible plants, fungus, right? Yeah. But chef mushroom, that's like all year around, right? So they say the best time to harvest chef mushrooms is in the fall or winter. That's what they say. Yeah. Yeah, but whatever. So, are we ready to get back to mathematics yet? Or are there something else to talk about? Okay, let's do economics, okay? Because I don't think I kind of get ready to get back to that liberal tree, okay? I'm not ready yet, alright? I need some break from this liberal tree. Partition tree. Nickname? Liberal tree, because it's left leaning, okay? So, uh, uh, economics, okay? So, yeah, supply and demand curve, okay? So, this proof of this Professor Alfred Marshallian supply demand curve is this, all right? He's not mathematically rigorous, okay? In Wikipedia article about him, his biography, they say he's mathematically rigorous. No, 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 they don't know what they're talking about. Okay? He's not mathematically rigorous. He's more intuitivist, intuition driven, okay? But we are relatively more mathematically rigorous than he, okay? We derive this transactional demand curve based on integration of population curve. First, we assume this flat Earth hypothesis where There's one person who's poor, one person who's middle income, one person who's rich, right? You integrate that, it becomes this curve, this slanted straight line, linear line, right? But when it's bell curve distribution, then it becomes sigmoid function, right? But our bell curve is not Gaussian normal distribution curve. Okay, it's just ad hoc. Is um, differentiation of sigmoid curve. Okay, but they kind of look the same, so we adopted that instead, right? To make our job easier. It doesn't matter. It's just modeling anyway. Statistics many times is art. It's not science. Okay, so they just design it. Okay, so like standard deviation. Okay, they want to make it differentiable, so they take instead of take averaging out this absolute value, they squared it and then take a square root of that. That's art. Okay, come on. Standard deviation is all art. Okay, so it's not too bad. Okay, they have some good reason to do that to make it differentiable. Okay, yeah, but it's an art, right? It's not statistics. Is not exact science. Okay, all those statistical tools like chi-square method, whatever, to what express correlation. I think, yeah, it's all an art, right? I tried to come up with my own theory about standard deviation, but I stopped doing that because too much mathematics, right? So, anyway, economics. Okay. So Professor Alfred Marshall, he got the demand curve right, kinda. Okay, he just didn't derive it mathematically like we did, right? But when it comes to supply curve, there's no such a thing as supply curve. Okay, so I mean, he used intuition, right? If price go up, if this particular product is very popular, yeah, there'll be more market competition, more market participant, imitators, or if you invent something, then you can patent it, and you can uh, not yeah. Sometimes you can sell your patent, but if you don't want to sell it, if you be the producer of this product yourself, then you can what you can do is you can produce everything, make your company public, so that there allows stockholders get money, produce. You can do that, and another way to do it is to give license to you, so that other people pay you royalty, and then you just collect the money, and other people produce under your permission. They pay you royalty. So they are your licensees. You give them license to make use of your patent and produce product and pay you money. It's that kind of like taxation, right? Yeah. So yeah, if this product become very popular, there'll be a lot of people producing it to make money, right? Yeah, your competitors or your licensees and so on. Yeah, like generic brand of drugs, right? Yeah, imitators or competitors. Okay, like Coca-Cola, Pepsi-Cola, right? Yeah, you have McDonald's, Burger King, right? Pizza Hut, Domino Pizza, right? Yeah, you have Kentucky Fried Chicken and more generic brand chicken in supermarket in that Delhi area, right? Yeah. So when price go up, supply go up, yeah, it does make intuitive sense. We get it, right? So supply demand curve, price equilibrium. It's not too bad a concept, not too bad a model, but what we did in transactional demand curve, transactional demand theory, transactional demand curve theory, we want it to be mathematically rigorous. Okay, so we don't in transactional demand curve theory we don't have separate supply curve at all. Okay. Then when does price equilibrium happens? Kind of happen in the middle. Okay. Why? Because there's a profit maximization point. Okay. No. We only have demand curve, transactional demand curve. Okay. And profit maximization, mathematically speaking, it happens in the middle. Okay, so that's the equilibrium, price equilibrium point. Okay? Yeah, you have straight line, right? And you have y-axis quantity, x-axis price. Okay, so along this straight line, negatively sloped. Okay, because if you lower the price, more people will buy. If you increase the price, less people can afford. Okay, this the traditional demand curve, right? A profit maximization point happen in the middle, mathematically speaking. Right? Yeah. That's the equilibrium point for us. So we don't have separate supply curve in traditional demand curve theory. Right? Why? Because supply and demand. So this proof of Marshallian model is that supply and demand, they are not independent curves. They are not independent variables. Okay. And we came up with the equation delta P is equal to delta D minus delta S, right? And we derived that formula. Okay. With shifting of transactional demand curve, alright? Yeah. So supply and demand, they're not independent variable because if you're a businessman, because Professor Alfred Marshall, he was not a businessman, he was academic. He was too theoretical. So he doesn't quite understand how business really works, okay? He was in Cambridge, not Massachusetts, Cambridge, England, right? Yeah, so he was way too theoretical, okay? So the way business works is that supply depend on demand, right? But not always. Sometimes supply creates demand, like brand new invention, right? But otherwise, supply depends on demand. If you're a businessman, you know what I'm talking about. You adjust your supply level based on demand level. So they are not independent variables at all, most of the times. Okay. So separate demand curve, supply curve, and intersection, that's wrong model. Okay, because that assumes supply and demand they are independent curves, independent variables, and they are not. They are not independent functions. Okay. So that's the disproof, right? Disproving something is very easy. You just need one counter example, right? So we'll take 5 minutes break, okay? And we'll talk about this delta P price change is equal to delta D minus delta S, right? One single equation, okay? You don't need like two curves like shifting. No, we don't need that. Okay, we just need delta P is equal to delta D minus delta S, right? And we're gonna verbally prove that equation, okay? Or derive that equation. just some informal review of all those things, important things that we proved or disproved, okay, in the past. All right, we'll take 5 minutes. I love this willow tree, young leaves. Fantastic. All right. Okay, we are just giving ourselves verbal compendium summary of all our past academic scholastic achievement, right? Important stuff. Easier but more important than what we do in mathematics, okay? Because we are dealing with pure mathematics when we do mathematics, okay? Prime number theory, partition function, Yeah, I mean, they can find some application later on in the future. Who knows, right? But yeah, let's get back to economics. Okay, so yeah, during my break, I thought about it and I got it. So delta P is equal to delta D minus delta S. Okay, so you pass the minus delta S to the left hand side, so it becomes, and swap it, right? Then delta D, demand change, is equal to delta P, price change, plus delta S, supply change. Okay? So when demand increases, then you have upper shift, parallel shift of this transactional demand curve. Okay? We call it Z curve. Okay, it's like kind of lazy Z Z Z. You're dozing off, sleeping, falling asleep, right? Lazy mountain, lazy Z. Okay. Yeah. Negative slope. Okay. X axis price. Y axis quantity. Okay. So if demand increases, it means parallel shifting, upward, parallel shifting happening. So how do we get to that curve in this price equilibrium? Okay, three ways that we talked about in the past. First, you don't increase the price, you just increase the supply level to meet the increased demand. Okay, so that's delta D is equal to delta S because delta P is zero. You don't increase price, right? You work overtime or you hire people, get an apprentice to teach you a secret recipe in your pasta restaurant. Okay, healthy pasta, healthy and happy pasta restaurant. Okay, yeah, go ahead, take the name. I give you for free. Okay, so in that scenario number one, okay, you just increase the supply level by hiring more people, working overtime, whatever, right? No price change. That's one way to do it, right? But if you don't increase supply level and if you don't increase price level, then price will still go up, not by money, but in terms of time. Because, like President Trump said, yeah, time is money. Why? Because if you have time, you can work and make more money, right? So time and money, they are copiums and they are interchangeable. They are convertible to each other. Okay? Because your time, if you work, you can earn some money. You're converting your time into money. Okay? So, by labor. Okay? Okay. So yeah, if you don't increase price, to this the scenario number zero. All right. So there are four scenarios. Okay. Let's just number it right. One, two, three, four. No. We start from zero. Okay. So scenario zero, one, two, three. Okay. Scenario zero, you don't increase price, you don't increase supply level. Okay. You work only 40 hours a week. You don't hire any new employees. Okay. Because you want if you're like me, you want absolute control of things. Okay. So you work alone. Okay. Kind of like solo protection. All right. Or solo filmmaker like I once was. Right. So like yeah, then people will pay with their time waiting in this long line. There's increased demand, more people, customers in your restaurant, but you're not increasing production, you're not increasing the price, and so people wait in line. There's those restaurants in every city in the world, right? Very popular restaurants. They don't want to franchise out, right? Family restaurants, right? Yeah. Some restaurants are like that, right? Hey, whatever. So people pay with their own time by waiting in line for like 1 hour. Okay. To eat your pasta, okay? So price increases in terms of time. And time is money, okay? So yeah. Scenario number zero. Scenario number one. You hire more people or you work overtime, more time, so but you don't change the price. Okay, so yeah, you meet the demand by increasing supply level. Okay, scenario number one. Scenario number two, you increase the price. You do not increase production level. You just increase the price. You still make more money. Why? More people demand it, but because now the price went up, only those people who can afford your increased price will come to your restaurant. Okay? Same number of patrons, customers, clients, but only the rich can come and you make more money without working more time, without hiring more people, just by increasing the price. Your menu, you strike it out, okay, white out, right? Instead of $10, you put it like $15, and same number of people will come, and you make more money. Okay, so that's scenario number two. Scenario number three, there's the profit brand new price maximization point, equilibrium point. Okay, you increase the price a little bit, and you increase supply level a little bit, and mathematically speaking, that's the second middle point in this increased demand curve. Okay, and that's the profit maximization point, like balance, middle of the road, Aristotelian or Solomonian middle of the road. Okay, and you maximize your profit that way. Okay? Increase the price a little bit, increase the supply level a little bit. Okay, yeah, and that's what most companies end up doing because it's equilibrium behavior, equilibrium point. Okay. Okay. Yeah. So that's delta P is equal to delta D minus delta S. Okay. So kind of informal proof, right? Yeah, but yeah, whatever. When it comes to humanology, okay, so maximization of happiness, uh, that's like it's also balance, right? You and the world, everybody else, you and everybody else, yeah, different. How do you maximize your happiness? Yeah, you change other people and you change yourself. Balance. Because if you don't change at all, if you try to change the world, it will make your life very difficult. Okay? But if you only always change along the world like mainstream, everybody do tattoo piercing and so you do tattoo piercing. Everybody do smoke marijuana, so you smoke marijuana. Everybody do pro LGBT, so you do that. You just chime in, join in, jump in the bandwagon. Okay, I don't think you'll be very happy in the end. Why? Because some of the ideologies, mainstream majoritarian ideologies, they are unsound ideologies. Okay, so you have to make this happy middle, balanced approach. You change a little, and you change others a little to make some balance. Fair enough? Yeah, that's humanology. Okay. Like pro-gayism, for example. Okay, so let's take 5 minutes break. Okay, and we'll talk some more about humanology, ismology. All right. Okay. Yeah, let's take 5 minutes. Yeah, we're taking break from mathematics, but we're keeping ourselves very busy, very productive. Okay, so We'll stop and restart, okay? So we'll take like 10 minutes break. Okay, I'll see you soon.